Assalamu alaikum girls, I am Miss Saima Khan and today we will have the second lecture from the atomic structure chapter. Previously, if you remember, we have studied that atomic structure, that the structure of an atom consists of three main particles which are electrons, protons and neutrons. That day I told you that we will be studying in detail about their discovery and their properties. So now we will start with the electrons. In case of electrons, we have seen that electrons are basically negatively charged particles and they were discovered in the discharge tube experiment. If you remember, previously we have studied the discharge tube experiment and that is also known as cathode ray tube experiment. So electron was first identified by Thomson in 1887 in the discharge tube experiment or cathode ray tube experiment. Sometimes this question comes in exams as short question as well as objective over there, that they ask about the scientist name and the year in which it was discovered. So you have to remember all this, that from the discharge tube experiment electron was discovered. Similarly, other scientists also worked on it, such as Faraday, Crookes and Goldstein. Now about the properties of the cathode rays. Each property is very important from short question as well as from your objective point of view. So please listen to it very carefully and try to learn them. First is that cathode rays are negatively charged particles. Now how is it proved that they are negatively charged particles? They have shown it with the help of experiments. J.Perrin worked on the magnetic field while Thomson worked on the electric field, and by their effort it was proved that electrons are negatively charged particles, or they can say that cathode rays are negatively charged particles. Now if you just see the diagram over there, there is present a discharge tube and that discharge tube has an elaboration in front of it where we have a fluorescent screen on which we have marked 3 points. We have two electrodes, one positive and the other negative, as blue and yellow color, and a magnetic field, that is horseshoe magnet, is applied over there. J.Perrin worked on the magnetic field and he saw that if we pass the cathode rays or the electrons from the discharge tube through the magnetic field, we can see that magnetic field has certain effect, or they show deflection on the cathode rays in such a way that all the cathode rays go and strike the point C on the fluorescent screen. It means that the cathode rays or electrons are being attracted from one of the poles, which is south pole in this diagram over there. Similarly, Thomson worked on the electric field. He passed the cathode rays through another electric field in which he passed it through the positive and negative terminal and saw that all the cathode rays were deflected on the fluorescent screen at point A, which indicates that point A is having a positive charge electrode over there. It means that something of opposite charge is present which is attracted by the positive charge. It means that the thing which is flowing is having a negative charge. That's why it is being attracted by the positive electrode, that is anode. Girls, this is very important short question, as well as a diagram is very important. They can ask you only that show with the help of diagram that cathode rays or simply the electrons are negatively charged particles. This is one of the very important point. Next point is that they travel in straight lines perpendicular to the surface of the cathode. That is, suppose say that at one end you have cathode and in straight line perpendicular to that cathode these rays will pass. They can ask you in short questions that explain that cathode rays or electrons travel in straight line. So this experiment which was done by Hittorf, and he proved that they travel in straight line. Now what thing proves it? That if we place certain object in its path, that is when electrons are traveling or cathode rays are passed in front, if we place any object excuse me, if we place any object in front of it, we can see that they have a shadow at the back of that object which is placed. If we place an opaque object in the middle and cathode rays are coming out, we can see that the back of the opaque object has a shadow over there, indicating that something straight is coming, hitting that object which is placed in the front and causing certain shadow over there. It means that these rays or the electrons which are traveling, they travel in straight line. All this diagram is also very important, and this is point is also very important from your short question point of view. Next, third point is that they are material particles and have momentum. Material particles basically means that they are made up of matter. How do we know that it is a matter? Because it has certain mass. And what is meant by momentum? When something has mass and it moves with certain velocity or speed, we say that it has momentum. Now, if we take again the same discharge tube and in the middle we place a pedal wheel, we can see that that wheel is moving. Apparently it seems that nothing is present and the wheel is moving on its own. Basically what is happening, that cathode rays are coming and hitting that wheel over there, forcing it to move in any of the direction, showing that the thing which is coming and hitting the wheel has certain mass, or you can say that they have energy and they are coming and hitting it and converting it to move over there. This all is also very important short question. Any of these three definitely comes in your exams, either home exams or in your board. So you have to prepare all these points along with the diagram very well. Fourth point is that they produce X-rays when they strike the anode. It means that when cathode rays are coming and they are striking the anode or the electrode, knocking out electrons from them, and in return energy which is liberated out is in the form of X-rays. So it means that the cathode rays have the ability to produce X-rays. Fifth point is that they produce heat when fall on the foil and foil begins to glow. It means that something, how can heat produce? When something is having certain friction or it has a high temperature. Definitely we are not providing it temperature, we are just bombarding on the foil the electrons or the cathode rays, so heat is produced. In return, the foil will glow with this color of which the foil is made up of. Sixth point is that they can ionize gases. What is meant by ionized gases? That they have the ability to convert the gas or the atom into an ion. How is ion produced? That when something comes and hit it, knock out the electrons from it and leave behind the proton or the nucleus. So we can say that they have ionizing ability or penetrating power. Next point is related to the same, this ionizing property or penetrating power, that they are capable of penetrating the material sheet. It may be aluminum, gold, any material sheet is placed, and they have the ability to go deep in it, knock out the electrons and ionize that substance over there. Eighth point is that electrons are part of every atom. They did different experiments and they find that whatever atom is present of any material, whether solid, liquid or gas, electrons are must part of that substance. So electrons and protons are must in every atom, while neutron may vary, and that is only for hydrogen. That hydrogen atom does not have any neutron, but definitely electrons and protons are must for every atom. Girls, all these properties are very important. They can ask you in your short questions, in your objectives, and even as a long question they can ask you to explain all the properties. So please do prepare it properly in very well manner. Next is that how can we measure the charge to mass ratio of an electron? The experiment which was done is very simple, that if we take a discharge tube and we pass the electrons or the cathode rays in it, they will go straight, because we have already studied that one of the properties that they move in straight line, that they move straight. So cathode rays would be moving straight and excuse me, would be hitting the point B on the fluorescent screen. Now if we apply different fields to it, such as magnetic field or electrical field, different observation will be observed. Now suppose we apply magnetic field. If we apply only the magnetic field to the cathode rays in the discharge tube, we see that all the cathode rays are coming and hitting point C of the fluorescent screen. It means that they are being attracted to any of the poles. In the diagram you can see that if they are coming and hitting at point C, it means that it is the south pole to which the cathode rays or electrons are striking or are being attracted. Now if we just only apply the electrical field, that is we have two electrodes, plus and minus, that is anode and cathode, one of blue color and the other of yellow color, and we pass the electrical field or we pass the electrons through it or the cathode rays. We just see that all those rays which are coming out, they are coming and striking point A on the fluorescent screen. What does it indicate? That they are, whatever thing is coming from behind, that is the cathode rays, are attracted towards the upper electrode, and the upper electrode is the anode, positively charged substance. It means positive will attract only the opposite charge, that is negatively charged substance. It means that electrons or the cathode rays are negatively charged substance. That's why they have been attracted towards the positive electrode. Now suppose we switch off both electrical and magnetic field. We just observe a very simple experiment that all the cathode rays will go and hit point B. Now suppose you turn both the fields, that is electrical field as well as magnetic field. You see another change over there, that now again the cathode rays are coming and striking point B, showing that neither they are being deflected by magnetic, neither being attracted by the electrical field. Both of them are cancelling each other's effect. That's why the cathode rays or the electrons are going and striking point B. Because this is very important. Mostly it comes in exams that explain with the help of experiment or with the diagram charge to mass ratio. Charge is basically represented by E and mass by M. They have calculated the charge to mass value of an electron and it came out to be 1.7588 into 10 raised to power 11 coulombs per kilogram. Girls, this value is very important. Mostly they do not give these values, you have to learn. Sometimes they do give, but mostly they do not. So it's much better that you should learn them rather than you should be depending that they should be giving you the values and you will be putting them in numericals or different calculations. So you have to remember this charge to mass ratio. Charge unit is in coulombs while mass unit is in kilograms. So the value is 1.7588 into 10 raised to power 11 coulomb per kilogram. I hope so that all of it is clear up till here. Next is that measurement of charge on an electron. That how do we measure the charge? Or they can even ask you, and it is really very important, that explain Millikan's oil drop method or oil drop experiment. Now what is over there is that we have an apparatus or a chamber which has two portions, an upper chamber and a lower chamber. You can see that both the chambers have connection with each other because the upper chamber floor has a hole and whatever would be present in the upper chamber can move very easily through this hole towards the lower chamber. You can see in the diagram that they have placed an atomizer, they have written, and oil droplet. Why is it known as oil drop method? Because in this experiment oil was used in the form of drops. Drops are quite big, so they used atomizer so that those big oil drops can be divided into very small, almost size of an atom over there. This experiment was done approximately 1500 times again and again, and then the conclusion was made. So with the help of an atomizer, oil is sprayed in the upper chamber in such a form that very small oil drops or atom like things are present in the upper chamber. There is present a small hole So all the oil drops which have the ability to pass through that hole will move to the lower chamber and will be attracted by the gravitational pull towards the lower chamber. It means something has mass, that's why it is being attracted by the gravitational pull. With the velocity with which it will be moving down depends upon the mass, because gravitational pull would be same for all the drops. Now they have shown two charged plates, one a positive and the other one with a negative over there. There is present a microscope, you can see in the diagram, as well as they have shown that light source is present, which is making all the air or any gas, whatever you have introduced in this chamber, that they are ionizing the gas over there, ionizing radiation. Now whatever gas is present or air is present in the lower chamber will become ionized, that is, will have negative charge as well as would have the nucleus. So now in the lower chamber, what things would be present? It would be oil drops, second would be the electrons, and third would be the positive charge, or you can see the nucleus. Now with the help of the microscope, they saw that now instead of these oil drops are coming down, suddenly they have turned on the electric field and both the electrodes, that is positive anode and negative cathode, both have turned on. When they have turned on the electrical field, they saw that now oil drops, instead of moving down due to the gravitational pull, are moving up towards the positive electrode. They were surprised that why oil drops are now moving in upper direction and not attracted towards the magnetic field. Then later on they concluded that these small oil drops which are now being attracted towards the positive electrode must have something opposite charge, that is, it must have negative charge. It is not that oil will be having negative charge, but maybe something which is attached to it would be having negative charge. So they saw that in this lower chamber, as electrons were present, they went and were residing on the oil drops. The speed with which the oil drops were moving upwards were not same. Some of the oil drops were moving very quickly upwards, some of them were moving slowly, and some of them were really very slow. What made this difference in their velocity occur? It is basically that all the oil droplets would be having the same mass, would be having the same size. But the difference which is present is because of the electrons which are present in this lower chamber are coming and striking or are sitting on the oil drops. If one electron is sitting or is residing on the oil drop, definitely the upper electrode will attract it slowly. Instead of this, if two electrons are present on the same one oil drop, the speed with which it will move to the upper electrode would be quite faster. And if we have 3 electrons present on an oil drop, the speed would be much faster. It means that oil drops which are present in the lower chamber do not have any ability to move to the upper chamber towards the upper electrode, rather than it is the electrons which are being attracted, or the number of electrons which will be present on the oil drops. More the electrons present, more quickly it will be attracted over there. So with the help of this experiment or Millikan oil drop method or experiment, they calculated the charge on an electron. Next is determination of mass of an electron. They can ask you in your short questions that how can we find out the mass of an electron, so you have to do all these calculations. We know that E by M ratio, just previously we have studied that E by M ratio is equal to 1.7588 into 10 raised to power 11 coulomb per kilogram. This is the first equation, and we know that charge of an electron is 1.6022 into 10 raised to power minus 19 coulombs. It is fixed, and you have to learn all these values as such, because in exams no one will provide you these values. If we take this E value and put it in the upper equation, that is 1.6022 into 10 raised to power minus 19 divided by M is equal to 1.7588 into 10 raised to power 11, and leave M over there, we can find the mass of an electron. And mass of an electron, whether it is of any atom, it is not that hydrogen will be having different mass electron while oxygen will be having different mass of an electron. No, it will not be like that. All the atoms will be having the same mass of each one single electron. More the electrons, more would be the mass. Less the number of electrons, less would be the mass. So the mass is also fixed, which is 9.1095 into 10 raised to power minus 31 kilograms. This is also very important. They can ask you in your objectives different values. So do prepare all these values and learn them orally. Next is, there is an example that how much heavier is the hydrogen atom as compared to an electron. Now, no values are given. You have to learn all these values as such. So mass of hydrogen atom is 1.67 into 10 raised to power minus 27 kilograms, while mass of an electron is 9.11 into 10 raised to power minus 31 kilograms. If we just put it in this equation, mass of hydrogen atom divided by mass of an electron, the answer comes to be 1833. That is, as we know that electron is a small unit or is a small part of an atom. So definitely hydrogen atom would be heavier than that of an electron. How much it would be heavier? And it is that hydrogen atom is 1833 times heavier than an electron. All this is very important, girls. Apparently it seems that it is very easy, you can learn it very easily, but when you start studies or when you start learning all this, do make the practice of it, because when you just see the diagram it seems that you can draw it very easily, but when you actually draw it, it is really difficult. So do try the practice of the diagram as well as all these calculations. It is very important. I hope so that all this is clear to you. Inshallah, next we will study the properties or the discovery of the protons. Thank you, girls. Khuda Hafiz.